Welcome to the CircuitPython show. I'm your host, Paul Cutler. This episode I'm joined by Scott Shawcroft, who is the project lead for CircuitPython. His work on CircuitPython has been sponsored since 2016. Prior to that, Scott spent 6 years working at Google and holds a degree in computer engineering from the University of Washington. Scott, thanks for being on the show.
Thanks for having me.
I was listening to a podcast you were on last year on the Real Python podcast where you mentioned that you had gone on show and tell a few times before you had the opportunity to join Adafruit. It was a really cool story. How did that happen?
Yeah, so I worked at Google for almost 6 years, and I decided that I was done with that. And so I took it ended up being about a year, but I was really into drones at the time. So I taught myself PCB layout and PCB manufacturing and all this stuff. And then I ended up porting an open source flight controller software to the flight controllers that I was making. And I started going regularly to show and tell to show that off, because I was also watching a lot of like Ask an Engineer and Desk of Lady Ada's to learn the tips and tricks for doing electronics manufacturing. And so
Sure.
at some point I started just like going on and being like, today on show and tell I'm going to talk about motors, or I'm going to talk about speed controllers or flight controllers, and kind of chronicle all of that as I was going along. um, and then I actually did like one manufactured batch from macrofab and started selling it, but I quickly realized that like to do a business there's a lot more than just the engineering side, and I really am like, my strength is in engineering, and I really had no interest in doing like product market fit analysis
Sure.
and product design and marketing and all of that other stuff. So I was keeping track of like I had set aside a certain amount of money to basically burn through, and I knew that I was like coming to the end of my time to not being employed. And so I was starting to look for jobs, and so I literally went on show and tell one of those weeks and said, "Hey, I'm looking for a job." And Phil is really welcoming, so he had like gotten my info before and like blogged some stuff up that I had shown before. And so the next day I got an email, just sitting here in the office, and got an email from Phil, just two sentences that said, "Hey, do you want to do stuff with us?" And I was like, "Yeah." And they were like, "Well, we have a particular project in mind. Is that okay?" And I'm like, "Yeah." And then they were like, "Hey, there's this MicroPython thing, and we'd like to experiment with getting it on our boards." And I hadn't heard of MicroPython.
Okay.
I had done Python for ages. Like I started doing Python in like 2005. So like I had done a decade of Python by this point,
Oh,
and it
wow.
it had always been my tool that I really liked. It was never really my day job to do Python, and it's still not really my day job to do Python. Uh, but it was a really good fit, because not only did I have all this experience with Python, but I had also spent the last year learning all of this embedded stuff. And so at the same time, I was getting kind of burned out on the quadcopter stuff, but I really learned that I liked hardware and I liked embedded a lot. So it was like perfect timing for me, and it worked out really well.
That's
Worked out
awesome. So
really
that
well.
was just over 5 years ago. Is that correct?
Yeah, that was like August of 2016.
So
So yeah.
as you think about the last 5 years, what are some of the biggest changes you've seen, starting from scratch to now? Or maybe I can rephrase that and say, what are the accomplishments you've done in those 5 years that you're most proud of?
Yeah, I mean, I think it's important to say that we didn't start from scratch at all, right? Like MicroPython was 2 years or maybe even 3 years old at that point, and Damien and all of the other contributors to MicroPython had done an awesome and continue to do an awesome job with MicroPython. So we're very much standing on the shoulders of giants. Um, but one thing, there was a few things that I brought kind of in that fall of 2016 that I think have really over the last 5 years shown that they were the right calls. Um, One was really focusing on USB. So actually, for the first three versions of CircuitPython, we had ESP8266 support as well. Um, and that was good in its way, but we really had to narrow down and say, like, we're just going to do USB. That was a really good call. And we continue to do really well with like keyboard and mouse support from CircuitPython, for
Sure.
example. So really focusing on USB has really been a great call. And then the other thing that we did in that fall that kind of we started with was uh, we chose to have a different layout internally to our source code so that we can know that our hardware APIs were identical across all the boards. Because my argument at the time and continues to be that like I had seen Adafruit really succeed in Arduino because they had built all of these drivers and examples on top of this uniform API that Arduino provided. So it made a lot of sense to me to really push to have what became CircuitPython also have that really pretty strict API to build on top of as well. And we've seen just the API that we ended up with has been really, really versatile and has actually, the core of it has not had a lot of changes since then.
Oh, that's awesome. So speaking of USB, for the first time in a long time, some of the USB requirements are changing where it doesn't have to
Yeah.
have a physical USB port. Is that the change?
Yeah, so that's definitely fast forwarding 5 years. One thing that I've wanted to do for the last few years in particular is support a wireless workflow. So I kind of think of it as a workflow as like how do you actually program CircuitPython, right? And we had focused really narrowly in CircuitPython 4 down to the USB stuff, and we were very strict until 7, where we relaxed it to include BLE. BLE is Bluetooth Low Energy. It's a very common protocol that phones and tablets and compute and laptops in particular can speak. And so by supporting a BLE workflow, what we're doing is we're allowing people to use phones and tablets in particular to program their device. So it's well worth the risk, but I'm definitely foreseeing that we're going to have to do a lot of messaging and marketing around like this is not the CircuitPython you think. And we were, yeah, Phil and I were, and Phil Lamore and I were just talking about like how we can make it clearer which version of CircuitPython you're actually dealing with.
That makes sense.
Um,
I'm embarrassed to say that just a couple weeks ago, I got to the last Ada box and started setting up the glasses that came out around
mm-hmm,
Halloween.
mm-hmm.
And I just wanted, I put it on Twitter. I had had the text scrolling across that said "Welcome to the CircuitPython show." And when I went to do that, it's like connect via BLE, and I grabbed my iPad and typed the text in on my iPad. I'm like, oh my goodness, this is cool. Um,
Nice. So it
that's got
worked.
to be that's got to make it so much easier for people that are new to hardware or new to the Circuit Python to actually get involved and get their hands on and start programming it.
Yeah, I mean that's my hope. My hope, the other thing that we did, there the technical things I just talked about were things that happened kind of in that fall. And then in the spring was really when we had to make a decision about were we going to try to upstream everything or are we going to kind of establish ourselves as something separate? And obviously, we chose to be something distinct. Separate is maybe not the right word, but that's when we settled on the name CircuitPython. We decided that we would keep this going ourselves for the longer term, um, and also it gives that branding gives us the very clear of like this is what you can expect from CircuitPython, and this is what is compatible with CircuitPython.
Sure.
Um,
So you mentioned upstream. How many of
mhm.
the things that you work on today do you actually push back upstream that they accept?
It's not a lot. There's not a lot that goes kind of back upstream. Where our repository is structured very differently for like most of the work in both MicroPython and CircuitPython is port work, meaning like supporting particular chipsets. And because we have a different hardware API, it's really hard to upstream that work. Where you will see some stuff kind of flow from CircuitPython back into MicroPython is more like we find bugs in the Python core.
Sure.
And the way that that works is it's not usually a pull request from us. It's more like an issue saying like, hey, we found this issue. Here's our copy of how we fixed it, and then they may or may not do it that same way. A big
But at least they know about the issue then.
Right, like we talk with the MicroPython folks, like we're friendly with them. So they let us know the things they're excited about, and we let them know the things that we've done. The bigger example is like compressing error messages. So like we did that in CircuitPython first in order to save space, and at the same time we did translations. So you can get a French version of CircuitPython that will have error messages in French and other messages in French, for example. Um, but in MicroPython, they chose to do a different approach. So
Sure.
they do compression, but they don't do translation.
Speaking of localization, how many languages is CircuitPython translated to today?
I'm not sure. I'd have to look.
All right.
I think it's over 10.
Okay.
But the quality of those will vary. So if a particular message is not translated, it will still show up in English. Um, and we try to have the core messages about like hit Control D to reload. Like we try to have those translated before we'll turn it on.
Okay.
But yeah, we're always looking for folks who speak other languages because that is not my strength.
Or mine. I have so much respect for people who can write documentation or contribute code in multiple languages.
Hmm.
So you mentioned a lot of the work is around porting to different pieces of hardware. You spent
Hmm.
the last couple of months of 2021 porting it to the Raspberry Pi single board computers. What were
Right.
some of the biggest challenges in actually bringing it to a full blown computer and not just a microcontroller?
Yeah, so it was very different. So I've been really interested in supporting the Raspberry Pi proper, the Broadcom chips, because they have really good HDMI support. So whenever we're working on something, it is a question of like, what does this new chip provide us that we can't get in other chips? So Raspberry Pis, everybody's got one. They're usually not being used, if in
Right.
my experience. And so it was like, hey, this is how in CircuitPython I can get access to a display. And you could always, or you could already do that with Blinka, but you still have all of the setup from Linux. And so I was really interested in this idea of like blowing people's minds of taking something that you would just put Linux on and make it so that you don't need to put Linux. You can get more of similar of an experience to what CircuitPython has on a microcontroller. So that's why I did it, and the challenge was different, somewhat different because there was a lot of differences in the way that the CPU actually works, um, how it handles interrupts. It's a lot of them are multi-core, although we're not using the multiple cores. Um, and there's memory mapped unit that doesn't exist in microcontroller land as well. So
Okay.
um, there was a lot of the CPU side to do, and then the peripherals are actually like not great. So the peripherals were actually like not as good as the ones that you'll find on a microcontroller. So figuring out how to get those to work okay um, was some of the challenge as well. So I'm happy where it's at, but there's definitely more work to do there.
There always is.
Yeah.
So when you mentioned the HDMI support, is it truly just plug and play? You flash it to the card, or
Yep.
you flash your SD card, you
Yep.
plug in the HDMI cable, plug in your power, and it boots right up to the REPL?
Yeah.
How do
Yep. Yeah. So just like all of our displays, if the board has a built-in display, you'll see the terminal on the screen. That's true for the Raspberry Pi boards as well. One of the caveats with Raspberry Pis is that they don't always have the USB plugs for to act as a USB device. So you'll want to check the Learn guide I made for like which of the many USB connectors on those boards is the one that you want. But for example, on the Pi 4, the USB Type C that you use for power actually can act as a USB device as well. So
Oh,
that's where
neat.
you'll get your CircuitPy drive and you'll get your CircuitPython serial. And in fact, it's just USB, and we use the same USB stack. So you can actually do the HID stuff that you can do. You can do the MIDI stuff that you could do because it's all the same code.
So it's almost like we're back to the 80s when I was a kid because I'm old, and you would take those Commodore 64s or a TRS-80 and plug it right into the TV, and
Yeah.
you're just programming.
Right.
It's like you have basic, and now you just have CircuitPython instead of basic.
Yeah, I mean, I've actually experimented with how you could edit Python code like you could edit BASIC on those computers. So where you put the line number and then the line of code that goes there.
Oh, neat.
I experimented with that. It's something I would love to do, and in fact, the Commodore 64 is definitely one of my inspirations for this. The Raspberry Pi released the Pi 400, which is actually a keyboard with a Pi 4 inside,
Right.
and probably the next thing I work on when I circle back to that is going to be getting the keyboard working,
Okay.
so that we can literally have that like circuit Python 64 experience or whatever you want to call it,
So
where you can edit it directly.
we're just going full on retro between your work on that and Lady Ada and Jeff Epler working on floppy disk support.
Yeah, I didn't know they were going to do that, but I'm pretty excited by it. I have an uncle that has a bunch of 8-inch floppies that he wants to archive, so I keep asking them when they're going to get to 8 inch.
Nice. Hi, it's Paul. I'll get you back to the show in just a moment. Thanks for listening, and if you like what you're hearing, hit the subscribe button and leave a comment that you subscribed. For other ways to support the show, visit circuitpythonshow.com/support. Now, back to the show. So now that you've wrapped up your Raspberry Pi work, you've started working on the ESP32 boards, is that correct?
Yeah, so particularly, we have existing support for the ESP32S2, which is the first Espressif board that has native USB support. So we were really excited about that. That was the first time we could actually put CircuitPython on a Wi-Fi native board because the other previous chips did not have native USB and therefore couldn't show up as the CircuitPy drive we all know and love. And since then, they've come out with the ESP, or they're kind of coming out with the ESP32S3, which is kind of a newer, beefier version of the S2, and it also has Bluetooth Low Energy in it. So this will be the first chip that we have CircuitPython support that can do Wi-Fi and Bluetooth
Oh, that'll be really
at the
neat.
same time. Yeah, I'm very excited about it.
So can you
Uh,
bring that experience that we were talking about earlier that I brought up with the glasses via BLE here on right on an ESP chip then?
That's the hope, yeah. We're
Oh,
not there yet, because it's not done.
one thing at a time.
I'm working on implementing it, but yeah, that's the hope, is that we'll be able to do the BLE workflow. You may have seen that we're also supporting the ESP32C3, which it does not have native USB, but it does have Bluetooth, does have BLE, and it's their first RISC-V core, which is what people have been kind of excited about too. So the
And for those that
C3
might not know, the RISC-V is...
RISC-V is like the API to the processor. So there's this notion of instruction set architecture, which is like what the numbers mean to the CPU, basically, like what the data in terms of commands actually means to the CPU. So it's not necessarily the CPU design itself, but it's the API that you use to use the CPU. And the nice thing about that is that's the API that like compilers produce code for. And so the benefit of having an open, so RISC-V is open standard, license free, so anybody can implement a CPU core. And if they implement that CPU core, whether it's open or closed, they can use all of the toolchain compiler infrastructure that have been built upon that API. So I think people get more excited than they should, because the reality for somebody like me writing software is that you're really just using a different compiler. But on the hardware design side, it's pretty neat because you're going to get a lot of different implementations of CPUs that can all use this existing infrastructure. Um,
So what is the benefit for the makers?
for RISC-V,
Yeah.
I think it's probably just a few cents in cost, right? So
Okay.
every ARM core or Extensa core is a licensed core, and that will add a little bit of cost to chips. Um, the other thing is that, like, because there are open RISC-V cores, if you had an FPGA design that you were doing, you could just plop that in and use that as well.
That makes sense.
But I don't expect a lot of people to be doing FPGA design.
Probably not at this point.
No.
In your spare time, you've been working on a website at wa-law.org focused on Washington State. Um, what
Yeah.
what spurred your interest in local politics?
This story kind of starts last year. I am obviously a technical minded person, and one of the things that is pretty common in the different states here in the U.S. is that some states have laws that prevent public entities from providing internet to people.
Community broadband.
Community broadband. There's a great podcast called Community Broadband Bits from the Institute for Local Self Reliance, if people want to go down that rabbit hole. Lots and lots of awesome people around the country who are doing municipal broadband and related things to get people primarily fiber internet, but not always. Um, and so in Washington State, we had a law that prevented public utility districts and port districts from providing internet to folks. Um, And last year there was two different bills that got passed by the legislature to remove those restrictions. Um, and one of them was more permissive than the other one. And so that got me kind of like more involved in this process of figuring out like, hey, there's these two bills that are going to get rid of this, but one is only like public utility districts, and one is like cities and counties and public utility districts
Sure.
and port districts and stuff. Um, so there was some drama around that because both bills passed and they both went to the governor, which is the next step after it goes through the legislature. And the governor signs them concurrently, one in each hand, which
That's
is not
awesome.
which is not the governor's job. The governor's job is to pick, in my opinion.
Oh, I see. Okay.
And so there was actually a lawsuit. The Secretary of State, whose job it is to order the laws, and the order matters for precedence if there's overlap. Um, so the Secretary of State had to file a lawsuit, said, "Hey, do I actually have the right to pick? And if I have the right to pick, what they did was they went by the order it was passed from the legislature, which turned out to be a good thing because the more pervasive one was passed second or first or whatever the better one is.
Okay,
I don't
good. That
even
was my next
remember.
question. That's good to hear.
So yeah, so as of July in Washington here, there's no longer this limitation. So public utility districts can provide retail service to customers rather than just wholesale to other entities. So that's really good, and that got me more involved in promoting public broadband throughout the state. And there's a lot of money coming in the U.S. here for more broadband. And so, as of as I learned more about how the legislature works, I got interested in collecting public data and trying to repost it and share it with people, um, to make it easier to understand and potentially like better cross-linked than the existing public resources are. So, for example, like look at a bill, see who sponsors it, and then go to a page that said not only says this person is on these committees and has these bills, but also like got their last campaign, they got this much money from these top donors, for
Which is
example.
good to know, and that should be public
And
knowledge.
it is
Easier
publicly
to
available.
access.
But like those two worlds, the legislative world and the campaign finance world, are very two different websites right now. And so like I haven't done it yet, but my intention is to like kind of like make Walla, or somebody mistook it for a different name, Walledge, for like legislature. So I'm like, I just bought the domain and I might switch it to that. We'll see. But kind of making that kind of a one-stop shop for like all the information about uh, the campaign stuff and all the legislative stuff.
And one of the benefits I think that you're doing on the site is that you're reformatting a lot of the text that's difficult
Yeah.
to read for the average, you know.
Yeah, yeah. A lot of it is, if you go on the regular site, a lot of it's in PDFs, and I don't know how good of a job they do making those PDFs accessible. But they do have a website where you can get XML copies of all of the bills as well, and they don't do any sort of formatting. And the thing that bothered me the most was some of the sections of the law include a lot of nested lists, like deeply nested, like 4 levels deep,
Sure.
and they don't indent them in the actual copy of the law. And so it's just like, how are you going to know like whether you're 3 deep or whatever? And so Markdown's great for this. So one of the first things I did was I was converting the legal text, the revised code, into Markdown as a way to format it better. And I actually did, like, the very first version of this website was actually a GitLab instance that I was running, because I really wanted like the Git workflow for laws, so I could do like, who do I blame for this? Git has blame, and so
Right.
you can see the history of different components of the law. Um, but I'm not really a sysadmin, so this current version is just a GitHub repo with Markdown that gets converted to HTML and then statically served.
Well, that's great
Um,
work. I mean, I think the key theme there is accessibility, whether it's
yeah.
accessibility to get broadband or accessibility to understand what the laws that are being passed and
Hmm.
who is supporting them.
Yeah, and also one of the main things that I'm trying to do with like the so there's like a 2-year cycle to making laws, and I have this like landing page where it's like, here's all the laws for this biennium, which is the 2-year cycle, and here are the ones that are coming up for committee. So when you can actually it's executive action or public hearings. So like trying to be more involved in actually giving testimony when there is public hearings, for or against bills.
That's
Um,
great work. Thank you
yeah,
for doing
so
that.
I'm nerding out on that. Like one of the themes between all I do is the things I do usually involve a lot of learning. So always looking for new topics and new things to learn, and how the law is made is one of them.
I can relate to that passion for learning. It's one reason that we're here today and listening to a podcast.
Yeah.
So the next question I have for you is one that I is a segment that I call Turn the Tables. I'm a big vinyl record fan. I've been asking all the questions. Here's your chance
Mhm.
to ask a question of me.
Um, I was a little worried that there would be duplicates on this, but I was curious just how you found CircuitPython and how you got into it.
I attended a Microsoft conference a year or two back, and I've been working on learning Python these last couple of years. And they
Mhm.
had a Python workshop as part of it. I think it was probably PyCon. And if you completed a couple of the tutorials that Microsoft put together, they gave you a $50 Adafruit gift card. So I bought a
Nice.
Circuit Playground Express, and it sat in my drawer for probably a good 6 to 8 months before I got it out. And then I did. And like everyone else who starts playing around with CircuitPython, you realize how easy it is to do some of these things with the various sensors and the NeoPixels built in.
Mhm.
Um, and then I came across a project that I was really interested in, speaking of vinyl records, where someone had used a Raspberry Pi to actually put NeoPixel strips. And when they wanted to go get a record, the the NeoPixel would light up on where the record is on the shelf, which got me thinking, okay, what other projects can I do? So my office is on the other side of where my record player is. So now I'm working on a project with CircuitPython that will display the album art on my desk, even though the record is, 15, 20 feet away. So
Right.
that's kind of how one thing just led to the other. And, like all the other makers out there, you can always do it better. And I keep learning. And, just like we talked about, I have a passion for learning. And I had been learning Python, and now I'm
Mhm.
learning CircuitPython, which has just been a great experience.
Yeah, and those things are like a lot of the things you'll learn do apply across them, which is awesome.
So the last question I like to ask all of my guests, you're going to start a new project that uses a microcontroller. Which one are you reaching for and why?
Well, uh, for me personally, I'm very excited for the S3. I was like up late last night thinking about the Bluetooth things that I could bridge to Wi-Fi. And so I'm pretty excited about that. Of course, it doesn't work yet.
Well,
Um,
one thing at a time.
and most of my projects I get excited about, and then I do the thing that I needed to do, and I like lose interest after I've learned all the stuff I need to make it happen, but don't actually make it happen.
I know that feeling very
Um,
well.
yeah. So yeah, the new ESP32S3 I'm very excited about. The RP2040 with the PIO is really interesting too. Um, there's lots of good options. I think I wouldn't really reach for a SAMD21, the M0, kind of the first chip that Adafruit brought me in for. However, I have one on my desk that I'm using every day because it's literally just doing a touch sensor. So when I do like capacitive touch, it sets a pin high, and like it's how I have this setup where if I put my hand on my trackball, it changes what my keyboard does.
Oh,
And
neat.
so I just have this SAMD21 that's is my hand on the trackball, and if it is, set this pin that then makes like pretends my keyboard has a particular key pressed, which then changes the layer of everything that it's doing, and that allows me to do left hand trackball, right hand just mouse clicks. So I don't actually have to do mouse clicks on my trackball. I can do it on the other hand
Well, that's
and
awesome.
let my left hand do all of the moving.
Well, that's all I have for this episode. Thank you for being a guest.
Thanks for having me. Thanks for doing this podcast.
It's my pleasure. We'll talk to you soon. Thank you for listening to the CircuitPython Show, an independent podcast with the people in and around CircuitPython. For show notes, transcripts, and to support the show, visit CircuitPythonShow.com or follow the show on Twitter at CircuitPyShow, that's CircuitPy Show. I'm your host, Paul Cutler, and I'll be back next episode. Don't forget to hit subscribe and stay safe.